So a previous video I shot was how to get ridge lengths and end of ridge king commons, king cripples, and king commons. So end of ridge king commons and king commons. But what about these broken hips here? How do you get the runs of these broken hips so we can multiply the run by the secant or line length ratio to get their actual lengths? And how do they frame? Now this is, excuse me, this is a model that we built, partially built model over there. You can see there's a broken hip right there. See, this little thing here. And so on this model, the one I showed you was this one here. How do you get these? There's two of them. You'll notice if you go down, this is going to have a right-handed, and this is going to have a left-handed cheek cut on the bottom. It's going to have a right-handed cheek cut. In actual point of fact, they're both double cheek cuts, like this drawing here. So here you have a valley coming up, dying into the ridge, turning and becoming a broken hip. Double cheek cut to illustrate this gap in between them. And this gap is because you go inside in the hip halfway, come out halfway, two halves make a whole. So the gap in between is the same thickness as the ridge that you're dying into, right? It makes sense. You go halfway into the ridge, halfway out, same thickness. You can run these down until they converge here. You have about a 1/4 inch left over there. And so you have two side cuts that are truncated, if you will. Or you can leave it and throw a block in there. This is just a fast way. If you're cutting your whole roof on the bench, it's easier to just cut a double cheek cut. The nails do the work anyway. So that's how that looks. Valley to ridge and then to broken hip, right? So you'll notice the broken hip has mathematically is to this framing point, but there's a deduction. Have half the 45 thickness of the 2x member or the ridge thickness. So in this case, it's a 2x ridge, so half the 45 thickness is 1 1/16 because the entire 45 thickness is 2 1/8. And you can find that out by just putting your speed square up on top and making a mark and measuring it, or do the math. Yeah, so, you know, LVL is 2.5, 4x is 5, and so forth, but 2x is generally 2 1/8, 2 1/4. So 1 inch subtraction at the bottom and at the top too. This is where the broken hip dies at the top. It's an additional inch from center line, you know. So basically subtract, this would be the framing point up top. So here it is here. How do you get its run? Now, if you look at this here, if you were to slide this, so this is the hip and the valley emanating from a consistent plate height, right? The valley plus the hip, broken hip, is the same length as the full hip. That is to say, without any deductions in the middle. So if this were to swing around like this length and this length would be the same. So that's the reason, right? They would parallel. They would meet at this point right here, right? So these parallelogram. So that's interesting because that would mean if you took the hip length, subtracted the valley length, that would give you the broken hip length. But you have to consider the deduction at the ridge, right? 1 inch, 2 inches, right? Or that is to say, if it was the valley at 1 inch, 2 1/8, and then continues on. So this minus an additional 2 1/8 will give you this. That's not how we calculate it. We calculate it by imagining this sliding all the way down to here. See? Slide it all the way down. This is a parallel, so if you did that, right? And then dividing it in half, you have this right triangle. So whatever this is the run, because you multiply the run times the secant for the hip valley line length to get, or the hip valley line length to get the length of the actual broken hip. So that means that And you can see that this is half of the plate length, and this plate length is 24 inches. So if you take 12 inches and you multiply it by 1.6 in this case, which is the hip valley line length ratio for the 9/12 pitch hip, which is actually runs at 9/17, that'll give you this length here, right? Stands to reason, right? Now the traditional way is to take the big span minus the little span, which would give you the difference, this much, right? Divide it in half, like we said, and then subtract half the thickness of the upper ridge and half the thickness of the lower ridge, then multiply it by the secant, which is 1.6. That's what we just did, but we didn't have to take the big span and subtract the little span. We just took the plate length, divided it in half. Now, what we didn't talk about is subtracting half the thickness of the upper ridge and half the thickness of the lower ridge. Now, this could be a 4x6, or I'm sorry, a 4x12 or whatever, and this could be a 6x12 or something. So that's why you have to subtract half the thickness. And when I say half the thickness, I mean not the 45 thickness, right? This is a 6x, it would be 2 3/4, right? And this would be, if this is a 4x, this would be 1 3/4. You'd subtract that from 12 inches. Then, when you got the remainder, because you can see these are perpendicular to that, so the deduction would be half the thickness of the ridge here and half the thickness of the ridge here, and the remainder would be multiplied by the secant, or the line length ratio for hip valley to give us the length in between. So now, if this was a 2x, which it is, and that's a 2x, half the thickness is 3/4, half the thickness is 3/4, together 1.5 inches. 12 inches minus 1.5 inches is 10.5. 10.5 times 1.6 is 16 something or something. So anyway, that's how long it would be, right? And yeah, so that's how you got that one. How do you get this one here? How do you get this one here? You could take the big span minus the little span once you find it, because this is right here is a variant plate, so you have to figure out what the real span is. Divide it in half. Subtract half the thickness of the upper, half the thickness of the lower, and multiply it by the secant the same way. You'll notice that this ridge and this ridge are at 90 to each other, and these two ridges are parallel. It doesn't matter, though. It doesn't matter. It's the same deduction. You can do that, or you can pretend that this line runs all the way down, right? We already know the ridge length, which we do because we calculated it by going 1, 2, right? Whatever it is to span is to span. We did it on the backside, measured in between, got the ridge length center to center. We subtract it from this, and it gives us the remainder, which in this case is 2 feet, the same as that, which means that this broken hip is the same as that one in terms of length.